We are looking at equations again today. Independent variables in a relation. We've already talked about that quite a bit. We talked about our independent is our input, and we have corresponding dependent, which is our output. In your ordered pair, the first coordinate is your independent. The second coordinate are your dependent. In your table of values, your independent is usually the first or left column, and your dependent would be the below or to the right. Mapping diagram, our independent arrows start at our independent and go towards the other side. And then on your graph, your independent is the horizontal axis, or your X. Your dependent is your vertical, or your Y. In an equation, you usually try to isolate the dependent variable on the left side or right side. It doesn't really matter to me if you pick the left or right. You're just trying to get it by itself. Usually when we talk about that, we have a Y equals. Okay, so if we look at this, dependent variable is your Y equal. That's your output. Your dependent is your input, usually your X. So if you look at this, our independent variable for our equation, 2 is a number, pi is a number. So R is our independent. That would be the one that we would actually plug in there. And C would be our dependent. Okay, so what C is depends on what we put in for R. Okay, for B, your independent along the x-axis would be your time, and your y-axis would be your height. Okay, it also works for written statements. So the amount of sap obtained from the tree is dependent on the time. So it tells you right in there that sap, or S, depends on the amount of time. So that would make T our independent and S our dependent. Okay, so we've talked about that quite a bit. You should be relatively comfortable with that for now. When we start to work with equations a little bit more, it can be really helpful. We talked about a little bit yesterday how it can help us create a table of values, ordered pairs, and all the other pieces of information we need. So if we create a table of values, again, our independent and our dependent are left and right. So when we make the table of values, X is independent. So we can pick any value in there. And what we're going to do is we're going to plug it into the equation. So don't forget that that's a negative. And I'm just going to pick a number. So I'm going to go -2. And you replace the X value with that value that you've plugged in there. So if I have a negative and a negative, that would become a +2 plus 3, so we would get 5. So that means -2 is our X, or our input, 5 is our output. So I'm just going to keep going with that. And we'll plug those all in. So we have -1 plus 3. That's going to give us 4. Substitute your input, and then you determine what your output is based on that input. And watch for your negative signs like that, especially if you have a negative input and you have a negative X value. Okay, and so that's what we're doing. You can pick any values for X. We could start at -100, we could start at +50. It doesn't matter. We just pick that value and plug it in, and that's how we create our table of values. So choose a value to put your input in, determine what your output would be based on that. Okay, we can also use an equation to find certain input or output values. Okay, if we're given a particular value, especially when we start to talk about word problems, we can use that equation. So if we're given the equation y equals 3x plus 4, what's the y value given our x value? So all you're going to do is look at what value are we given. That's going to be replaced in brackets in your equation. Okay, so I want to see the actual replacement of it. And then if you would like to, you can evaluate, or you can go straight to your answer. So given our x value of 3, our y value would be 13. Okay, and that can work with any value. It doesn't have to be x. We can also be given a y value. And we can replace our equation, our y equals, with that value we're given. In this case, however, it's not as straightforward as just evaluating. We do have to manipulate our equation. So remember, we're trying to get x by itself. We're going to move what's farthest away. So we would subtract 4 from both sides. And then because the 3 is being multiplied by the x, we divide by 3. And we end up getting -2 is our x value when y is also -2. Okay, what is the value of x when y is 0 in the equation? So y is 0. Try it again. X is 0. We replace our value, so we're given a y value of 0. We have to then manipulate the equation. Whoops. So we get 12 equals -3x. Divide by that -3 to get x by itself. And we get x equals -4. Okay, you would do the exact same thing with x, and it would be more like the first question we had there. Okay, so take a minute and actually talk through this. Pause the video. What is a relation? How can you represent relations? How can you tell if something is a function or a relation in the various forms? In the equation, how would you identify your independent and dependent? And then how can we find an x value when we're given a y value, and vice versa? Okay, this is in your workbook, page 404. We're going to put all of it together. Okay, so we are given the equation y equals 2x minus 5. Complete the first 5 rows of the table, which show some of the possible input values. So again, all we're going to do is we're going to come to our equation. We're going to replace our x value with our given input value to determine our output value. Okay, you don't necessarily always have to show it, but until you get comfortable with that, actually write it out. And again, remember, anything times 0 is 0, so just watch for that. Sometimes people will rate that as 2. And you might start to see a pattern. Okay, what's happening every time? And it should be consistent if we're talking about something that's linear. We're going to have a consistent rate of change. Okay, and then we can create an ordered pair from that. So remember, an ordered pair needs to have brackets, and it's just our x and our y values. Our x values first, or our input is first, and then we have our output after that. Okay. What's the independent variable in the equation? What's the dependent variable? So remember, our independent is the x value, or often is the x value. Dependent is our y value. And when we plot our ordered pairs, I have a graph. I'm not actually sure if that's on yours, but if so, great. Remember, our x value comes first. So we want to look at our ordered pair for this, because that's going to tell us how far left or right we go and up or down. So if we have -2, we start at our origin, and we're going to go 2 to the left, and then it's -9, so we're going to go down 9, and that's our first ordered pair. And then you're going to just do the same process every single time. 0, 5. 0 means we're not going to move anywhere. We're just going to go down to -5. 1, -3, +2, and -1. So there's our ordered pairs. Connect the points on the grid and extend the line in both directions with an arrow. Please use a straight edge. Your graphing calculator case can actually function as a straight edge as well for you. Okay, so make sure you extend it as far as you can on your graph until you have the edges, and don't forget, I want to see arrows on both ends of that. Even if it doesn't say so, please put arrows, because we're given an equation. We can keep going in either direction. We are just plotting a piece that we know. Okay, use the graph to determine the value of y when x is 6. So when we're looking at that, we can go to when x is 6. So line up your straight edge, a ruler, something to that extent. And we can look at, go up to your graph, and then spin your ruler or your straight edge and go to your y from there. I think my graph's a little off. Okay, and we can confirm that. So my graph might be slightly off because of my ruler on here. Yours might be a little bit better. So when I put that in, it should be at exactly 7. So yeah, my graph's not perfect, but that's your general idea, is you're going to go up to the graph and then over to the other axis that you're looking for. So we would say y is 7. Hopefully your drawing's a little bit better than mine. Okay, so then use the equation to determine. So that's what I just did to check mine. So we have y equals 2x minus 5 is our equation. We substitute and we get 12 minus 5, which gives us 7. Okay, so if your graph is a little bit off, you can always double check using your equation. But in general, that's how we're going to look at it. And we talk a little bit about interpolation, is looking at within your graph at points that are beyond what you actually determined in your table. Okay, so then we're going to add this to our table. Our x was 6, our y was 7, which gives us an ordered pair of 6, 7. Use the graph to determine the value of x when y is 3. So this time, we're going to go to y is 3, line up your straight edge, and again, we know my graph's a little bit off, but this gives you a decent idea. You're going to line up your ruler at your y value of 3, ruler, straight edge, and whatever you got. You can eyeball it if you need to, and then spin your straight edge, or if you can eyeball it pretty easily, you're going to go down to the x-axis to see where should I be. And we end up with 4. So we get wrong area. Okay, so that gives us another one. We have an x value of 4 when our y value is 3. Gives us another ordered pair. Now, typically when we see a table, they're in sequential order. So you would generally see 4 above that 6 for x, but it's okay. This relation is called a linear relation because the graph of the relation is a straight line. Okay, you are going to give this one a whirl. I will post the answer for it, and then we can work on the practice question. Your quiz is going to be Friday. Okay. If you have any questions, write them down, and I will talk to you tomorrow.